If I could describe STEM in one word, it would be one of a kind.
Inspiring.
Difficult.
Collaborative.
Troubleshooting.
Tedious.
Realistic.
Amusing.
Life-changing.
Challenging.
Beta.
Entrepreneurial.
Commitment.
Rewarding.
STEM here at Carmel is a group of 14 students where we actually get to collaborate together and completely on our own make an experiment that we have to fit into a micro lab. It's about a soda can sized box that we send to the International Space Station for 30 days. The experiment runs before it's sent all the way back home where we can get our data. It's pretty amazing.
Our experiment is testing the fermentation rates on yeast when exposed to tardigrades in microgravity. The application points that we have are agriculture and then also biofuel.
STEM also provides many other opportunities, such as attending the ASGSR conference.
The ASGSR conference, standing for the American Society for Gravitational and Space Research, was attended by 7 members of the STEM team in October 2016 in Cleveland, Ohio. We had the opportunity to attend various seminars where scientists shared scientific concepts, past experiments, data, and experiment conclusions, among other things. We were also given the chance to present our experiment posters from the past 3 years in the high school poster competition.
In order to prepare for the final experiment aboard the ISS, we must first conduct a control experiment here on Earth.
The purpose of this control experiment is to gather data as a baseline to compare to the effects of microgravity on the fermentation of yeast in tardigrades.
At the beginning of our control experiment, we used 6 test tubes with different variations of glucose water solution and duration. This was the first step in creating the ideal ratio of the glucose water solution for our experiment.
Our final microlab requires collaboration among our software, electrical, and mechanical engineers.
The electrical engineers are the bridge between the mechanical and software teams. This year, the mechanical team wanted to use an alcohol and a temperature sensor to measure the ethanol and temperature in a chamber every 4 hours. The electrical team will find the appropriate sensors and solder them to a PCB board, which allows the software team's code to turn on the sensors every 4 hours.
Being on the electrical team also involves having many boundaries that we have to work around in regards to power draw. We have to be very innovative when it comes to keeping our current draw as close to under 100 milliamps as possible. For example, your standard light bulb uses 500 milliamps. This is done through finding sensors designed for low current draw and also wiring the sensors so that they draw the least amount of current as possible.
As part of the software team, our job is to write the code so that the experiment will work.
Valley Christian, our partner school, sends us a code template which we call the BIOS.
After we receive this template, we spend hours upon hours writing our own code specific to our experiment. This includes sensors, water pumps, and several other things. This also takes a lot of hard work, leadership, and communication.
The first part of the mechanical process is to create the microlab and a computer program called AutoCAD Inventor, and then we send it to a company to be printed.
Inside that microlab, there is a bag which contains a glucose solution which is then sent to a pump. That pump supplies the glucose solution to the fermentation chamber.
Beginning in August, it all starts as a concept, then a drawing, then an engineering unit, and finally a completed flight unit in February.